So good morning children, welcome back to our video classes. From today onwards, we planned to publish the Cbse plus 2 physics problems and the solutions in our YouTube channel. So every day you can get the solutions in our YouTube channel at evening 8 o'clock. Okay? Okay dear. Right. So the first question, what is the force between two small charged spheres having charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air? Okay. So two charges can be taken as Q1, 2 into 10 to the power minus 7 coulomb. Q2 is 3 into 10 to the power minus 7 coulomb. Placed at a distance of 30 centimeters. So R equal to 30 centimeter. Convert the centimeter into meter. So 30 into 10 to the power minus 2 meter. Okay. In air, which is placed in air, two spheres. Okay. So this is the first sphere and this is the another sphere, second sphere. So it may be first and it may be second. They are separated by a distance of 30 centimeter. 30 centimeter in air. So 2 into 3 into, so it is positive, it also positive. So these two positive charged spheres are separated by a distance of 30 centimeter in air. So it experiences a repulsive force. Repulsive force. Why? The like charges always repel each other. Okay. So what is the force? Okay. So what is the formula to calculate the force? It is F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay. 1 by 4 pi epsilon 0. That is 9 into 10 to the power 9 into Q1. 2 into 10 to the power minus 7. 2 into 10 to the power minus 7 into Q2, that is 3 into 10 to the power minus 7. So 3 into 10 to the power minus 7 divided by R squared. So what is the value of R? 30 into 10 to the power minus 2. So 30 into 10 to the power minus 2 into 30 into 10 to the power minus 2. Okay. First we can take the numbers. Okay. So 9 into 2 into 3 divided by, in the denominator, we can take 30 into 30 into, now you can go to the powers, 10 to the power 9, here minus 7, here it is minus 7. The minus 2 goes to the numerator as plus 2. The minus 2 goes to the numerator as plus 2. Okay. Now, 3 3s are 9. 1 3 is 3. For 0, it's 0. 1 3 is 3. So, 10 3s are 30. Now, 3 2s are 6 into 10 to the power. 2 plus 2, 4. 4 plus 9, 13. 13. Minus 7, minus 7. Minus 14. Okay. So, minus 14 plus 30. So, we can get minus 1. In the denominator, we are having 10 into 10. That is 10 squared. The plus 2 goes to the numerator as minus 2. So 6 into 10 to the power minus 2. Already we are having minus 1. So minus 1, minus 2, minus 3. So 6 into 10 to the power minus 3 is the force. So unit of force is Newton. Okay. So this much of repulsive force experienced by two positively charged spheres. Okay. Do you get it now? Do you any doubt? No doubt. Okay children. Let's go to the second problem. The electrostatic force on. So here the word on is the important one. On a small sphere due to a charge of 4 microcoulomb. Okay. So the charge Q1 can be taken as 0.4 microcoulomb. Now convert the microcoulomb into coulomb. So 0.4 into 10 to the power minus 6 coulomb. So to convert the microcoulomb into coulomb, so it is multiplied by 10 to the power minus 6. Due to another sphere of charge minus 8. Okay. So Q2 is the charge of minus 0.8 microcoulomb. Once again, convert the microcoulomb into coulomb. So minus 0.8 into 10 to the power minus 6 coulomb. Okay. Now, in air is 0.2 Newton. Okay. So, F equal to 0.2 Newton. What is the distance between the spheres? Okay. So, we have to calculate the distance. Okay. So, how we are going to calculate the distance? Okay. So, let us consider a sphere of 0.4 microcoulomb. It can be taken as Q1. Okay. So, Q1 which has 0.4 microcoulomb of positive charge. Okay. Now, another sphere of 0.8 microcoulomb. Okay. So, this is the another sphere of charge Q2 equal to minus 0.8 microcoulomb. Okay. And it is negatively charged. Okay. So, first one is positively charged and the second one is negatively charged. Positive and negative always attract each other. So, it experiences a attractive force. First one. It experiences a attractive force. Okay. Of 0.2 Newton. Okay. Once again, we go to the first word. Electrostatic force on 0.4 by 0.8. So, 0.8 is the charge. Experiences a force on the first one is 0. So, how we can write? Force on first sphere by the second sphere is 0.2 Newton. Okay, do you get it now? So, this is the meaning of on. Okay, now we can relate force, charge and distance. So, how we can relate? F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Now we can substitute the value F. So what is the value of F? That is 0.2 equal to 1 by 4 pi epsilon 0. 9 into 10 to the power 9 into Q1. So what is the value of Q1? 0.4. So 0.4 into 10 to the power minus 6 into Q2 is 0.8. So 0.8 into 10 to the power minus 6 divided by R square. So the distance only we are going to calculate. Okay. So the division R square comes to this as multiplication R square. Okay. Now we can take all the numbers separately. So 9 into 0.4 into 0.8. The multiplication 0.2 goes to right side as division. So 0.2. Okay. So in the denominator we are having one decimal point. So it is multiplied and divided by 10. Okay. Now we can go for the powers. Okay. So 10 to the power 9 minus 6 minus 6. Okay. Do you get it now? Okay, fine. Now 9 into 10 into 0.2. So it becomes 2. 10 into 0.4. It becomes 4. Into 0.8. Into 9 minus 6. 3. 3 minus 6. 10 to the power minus 3. Even now, we are having one decimal point. Once again, it is multiplied and divided by 10. Okay, right. Now, 1, 2 is 2. 2 2s are 4. For 1, 0, we can take 1 digit. Okay, so R squared equal to 9 into 4. So, the 4 becomes 2. Sorry. 2 into 0, 1 decimal point. So, it becomes 8 into the power plus 1 goes to the numerator as minus 1. Already we are having minus 3 and this minus 1. So, it becomes minus 4. Minus 4. So, we are having square. To take the square, we can put the square root. So, R equal to square root of 9 into 2 into 8 into 10 to the power minus 4. Okay. So, 3 3s are 9. 1 2 is 2. 2 2s are 4. 4 2s are 8. Into 10 to the power minus 4. 10 to the power minus 2 into 10 to the power minus 2. For these 2 3s, we can take 1. For these 2 2s, we can take 1 2. Here for 2. You can take. Here it's 1. So 10 to the power 9. So 2 2s are 4. 4 3s are 12. Into 10 to the power minus 2 is the distance. So many meter. So by taking 10 to the power minus 2, we can write 12 centimeter. So this is the answer for the first question. What is the distance between the two spheres? Is 12 centimeter. Okay, the second one. What is the force on the second sphere due to the first? Okay, so we know that the Coulomb's law of vector. Okay, so what is Coulomb's law of vector? Force on first by the second is equal to force on second by the first. So both forces are equal but acting in the opposite direction. Okay, so the minus sign gives only the direction. Which direction? So opposite direction. Okay, now once again we go to the word on. On 0.4 by 0.8. So 0.8 is the second sphere. So second sphere experiences a force on the first one. So F12 is 0.2. Okay, so what they are asking? Second sphere. Okay, so first one experiences a force on the second one, F21. So both forces are equal but acting in the opposite direction. So F12 is 0.2 Newton. Okay, so force on the, what is the force on the second due to the first? So the force experienced on second by the first is also 0.2 Newton, but it is acting in the opposite direction. Okay, we can say it also experiences, or it also obey Newton's third law. So what is Newton's third law? Every action has equal and opposite reaction. Okay, do you get it now? Do you have any doubts? No doubt.